So thank you very much. It's nice to be back to ONR. I haven't been here very often, but this is, I think, the second visit to this facility anyway, and we've now concocted a reason for coming back a third time. I have cheated a little bit today, as you can tell, maybe if you can actually see these slides, that these slides were prepared in December of 2013, and I did a very minor set of revisions, hoping that this skeleton would generate enough conversation that you'd go away feeling satisfied that you at least heard yourself speak, if you hadn't listened to what I had to say. My purpose in this set of slides is to characterize how the US government demonstrates or has demonstrated its ability to initiate major change and then to step away from it at appropriate times, essentially distancing itself from control and deliberately pushing it into the private sector. And I would argue that this has been generally characteristic of a great many of the research activities supported by the US government, including ONR. And so it's that theme that I am trying to emphasize, but I've chosen a kind of a calendar-like walk through the development of the internet. And what I will try to emphasize is the places where government has deliberately stepped away and pushed this out, control of it out into the private sector. So I thought I'd start though by showing you a cartoon that you may not be able to read that from here. It says, the guys over here in the bush hats are saying, stay downwind and back away slowly. The last time I heard of these things got spooked, the internet got created. And there's a whole bunch of guys with pens in their pockets, the usual, engineering thing. It's not half wrong, actually, because, a bunch of geeks got together and figured out how to do this. This is the original predecessor to the internet. It was called ARPANET for obvious reasons, and all of you know that. What's interesting is that it started out not so much as it wasn't motivated as much by technology as it was by an economic problem. At that time, ARPA, with the cooperation of ONR, I might add, as agents for contracting and programmatic oversight, was sponsoring research in artificial intelligence and general computer science at a dozen universities around the United States. And every year, each of the computer science departments would say to DARPA, you must buy us a world-class, latest computer so we can do world-class research. And even ARPA couldn't afford to spend that kind of money, because back then, we're talking late 60s, those computers cost millions of dollars each when dollars were actually worth something. So they said, we can't buy all of you new computers every year, so we're going to build a network and you can share. So this was a resource sharing network. But it was built on packet switching technology because at the time, the only other networking technology available was the circuit switch telephone net. And even to a neophyte, the idea that a computer would dial up another computer, wait for a connection, send some data, hang up the phone, dial another computer, didn't make any sense given the rate at which computers might need to shift data around among a collection of different machines. So packet switching was the primary motivation behind building this thing. I was at UCLA as a graduate student and wrote the software that connected the Sigma 7 to the first IMP that was installed in September of 1969 at UCLA. Of course, the Sigma 7's in a museum now, and some people think I should be there in the museum along with it, but here I am. This is what a packet switch looked like in 1969. It was the size of a refrigerator, and it was delivered to UCLA in heavy metal because the guys at Bolt, Beranek, and Newman who designed it knew that it was going into a highly hostile environment, graduate students and undergraduates, and so they figured we'll put it in this heavy metal sleeve. And it still is at UCLA. It's in Leonard Kleinrock's sort of museum where a lot of the artifacts from that era have been left. And at the same time, we were worried about the use of computers in command and control. And so Bob Kahn and I got together in the spring of 1973 when I was at Stanford University, and he had moved to ARPA from Bolt, Beranek, and Newman. And he said he was working on mobile packet radio to complement the wireline packet-switched ARPANET, and also a packet satellite system so that ships at sea could communicate through satellite or ship-to-ship or ship-to-shore, and that mobile vehicles could communicate or aircraft communicate using packet radio. And so when we met, he said, "We have a problem." And of course my reaction was, "What do you mean we?" And he said, "Well, you know, you're drawn into this problem of connecting different kinds of packet switch nets together." That's what the internet was about. So one of our most interesting experiences is at SRI International, built this van, kind of nondescript, unmarked van, which contained cubic foot packet radios. Those white things were about a cubic foot each. They cost $50,000 a piece in the mid-1970s. They ran at between 100 kilobits and 400 kilobits a second, which was pretty good at the time. And they used spread spectrum technology in order to be below the noise floor. We were spreading across about 140 megahertz of bandwidth, 1710 to 1850. This was very advanced equipment for its time. And of course, we would bring the military out to try these things, and it was a religious experience for them because they get in the van, we drive along, the data would be flowing through the radio systems, we'd park under a bridge, the data would stop because we're in radio shadow, and then we'd drive out and it would start up again. We had one guy, General Starry, some of you may know him. He was in command of the 5th Corps or something, I guess, in Europe, and was not having a good time with the radios of the time. He was running his reforger exercises from a telephone booth in Germany. He was really not happy about that. So he said, as soon as we took him in this thing and showed him at work, he said, "I want 50 of these delivered to my facilities in Germany next month." And we said, "But sir, these are experimental and we don't know if they'd hold up very well." "I don't care." So one other thing that I want to draw your attention to, because this was very important to ONR as well, we were very interested in using packet switching for both voice and video as well as data. And so we had help from Lincoln Laboratories and others to build packetized voice systems, which took, remember, we only had about 50 kilobits of bandwidth in the ARPANET. That was the backbone speed of the time. And we had between 100 and 400 on the radios and 64 on the satellite system. A normal packetized voice stream would be, a normal digitized voice stream would be anywhere from 64 kilobits to maybe you could do differential coding and get it down to 32. You can't get a whole lot of 32 kilobit traffic through a 64 kilobit network. So we had to use a compression method, and one of them was called LPC10, linear predictive code with 10 parameters. It modeled the voice tract as a stack of 10 cylinders whose diameter was changing as the voice was speaking, and then a formant frequency would drive that. And so you just send the 10 parameters plus the formant frequency over to the other side. That compressed the speech down to 1800 bits a second. On the other hand, the speech was not exactly perfectly rendered at 1800 bits a second. It made anybody who spoke through the system sound like a drunken Norwegian. And by this time, this is the mid-70s, I'm at DARPA, running the program. And I was asked to demonstrate the packetized voice program to some generals over at the Pentagon. And I remember thinking, how am I going to do this? And I thought, well, wait a minute. One of the guys that's working on this program is Ingvar Lund from the Norwegian Defense Research Establishment. And so we had Ingvar speak through the Autobahn system. Then we had him speak through the packetized voice system, and it sounded exactly the same. We didn't tell the generals that everybody would sound that way if you went to them. So that was my escape from discovery. The thing I also want to point out, I think I can get, yes, here we go. Marvin Denikoff was a legend, at least around my shop at ARPA when he was here at ONR, because he was so gung-ho on artificial intelligence. Really pushed hard. This book, Funding a Revolution, was written, I think, in 1999, but it makes reference to ONR's interest in artificial intelligence, which continues to this day. And I remember that Marvin and Bob Kahn were very, very active in collaborating with each other on promoting this stuff. And one of the things he was very interested in was speech understanding. And so at SRI International, that work culminated in several dimensions. We had a system that you could speak to it and ask questions, and it would show you maps and things in response. So we could say, show me all the Soviet submarines within 50 miles of the JFK. And it figured out the JFK meant the aircraft carrier, not the airport in New York. And it would respond by putting information up on a map and showing where that was. So we demonstrated that capability in the late 70s and early 80s. The speech understanding system emerged out of SRI International as a company called Nuance. And I sat on the board of Nuance, quite independent of anything else, for several years in the 2000 to 2010 period. But that came out of SRI International, and its success is partly the result of funding by ONR. So let me now show you how primitive the technology was of the day. This picture was taken in 1994, celebrating the 25th anniversary of the ARPANET, which had been installed in 1969. John Postel is the guy who was the Internet Assigned Numbers Authority. He was responsible for managing the domain name system, managing IP address allocations, and editing all of the RFCs that documented the ARPANET and the Internet. Imagine one guy under contract to originally ARPA and then later to NSF, and then I don't remember what happened after that. Then the Department of Commerce, NTIA, took over the responsibilities for that. John unfortunately passed away in 1998, but this picture was taken with his and my good friend Steve Crocker, who is now the chairman of the board of ICANN, the Internet Corporation for Assigned Names and Numbers. Steve was a guy that was at UCLA along with me and John doing the original ARPANET work, and he's the one that started the Network Working Group program, which today you would recognize as the Internet Engineering Task Force. Steve is the guy that started the RFC series in April of 1969, and John became the editor. So the three of us spent the entire day organizing this shot, drawing pictures of, on a big giant piece of paper. You can see, however, how primitive the communication technology was. It took us a day to get the squashes, the green zucchinis and the yellow squash, and there was a plastic cable. We had to empty 5 pounds of coffee out of the tins. But you'll notice that this network would never work because it's either ear to ear or mouth to mouth, but none of it is mouth to ear. And this was our geek joke for Newsweek magazine, because we figured they didn't get it, but we thought the geeks who saw this picture would get it. So that was fun. This is a very important date for me personally. I was here again in the DC area and wanted very much to show that the internet would actually work with more than 2 networks. So in this case, we hooked up the packet radio net, the ARPANET, and the packet satellite net, which is over the Atlantic, together as one giant internet. So this is the very first demonstration of a 3-network internet. We arranged for the packet radio van to go up and down the Bayshore Freeway. We were moving packets through a gateway into the ARPANET, went all the way through ARPANET over an internal synchronous satellite link to Norway, and then down by landline to UCL in London, out of the ARPANET into a gateway, and then into the packet satellite net, which went through a different synchronous satellite, Intelsat 4A, came down in Etam, West Virginia, went through another gateway, and then all the way across the ARPANET to USC Information Sciences Institute in Marina del Rey, California. Now, the distance between San Francisco and LA is about 400 miles. The packets went 100,000 miles because they had gone up and down twice to synchronous satellite height and back and forth across the Atlantic in the United States, and it actually worked. And I remember, leaping around saying, "It works, like it couldn't possibly work." It's software, right? It's a miracle when software works. So I was pretty excited because that demonstrated that we could take 3 very, very different packet switch nets and make them look uniform from the edges. And that, of course, has been the heart of the internet's development. Of course, that's what the internet looks like today. This is actually drawn automatically by a program that's taking the global routing tables and each color is a different autonomous system, different network. The point about this chart is that every one of those networks is independently operated. This is not centrally controlled. These guys decide what equipment to buy, what software to run, who to connect to, and under what terms and conditions. Nobody is dictating any of that to them. Nobody's dictating prices to them. Nobody's dictating business models to them. Some are for-profit, some are not for-profit, some are government, some are just private stuff like you and I run in our homes. That system is fully distributed, and except for the fact that ICANN, and before that John Postel, had to make sure that you assigned IP addresses uniquely and domain names uniquely. That's all it does, is making sure of uniqueness, and even that's a hierarchical structure. The rest of it is fully distributed, and that was pretty important. So this is a picture of what internet governance looks like, and don't worry about it. The lower layer protocol stuff, this is ICANN stuff is down here. The rest of it is law enforcement, copyrights, intellectual property management, patents, business deals, all legal frameworks, law enforcement, the whole shebang. It's just an enormous and complex territory. It's not just about technology. Okay. So this is now, I want to step through the milestones and try to emphasize for you where government made important decisions that allowed this system to flourish. And it was largely by removing itself from control. Because during the early days, Bob Kahn and I wrote all the checks, wrote a lot of the documentation, did a lot of the design, worked very closely with the programmers, and we were basically in control of what the internet was doing. But that was in the very early days, in the early 1970s. So we get the ARPANET stuff happening in 1966 to 68 and 69. Steve does the network working group. He's just a graduate student, and ARPA tells him, go figure out how to organize these people so they can design protocols that you can use this expensive system we've just built. Electronic mail gets developed in 1971 by Ray Tomlinson, who just passed away just a couple of weeks ago. But Ray had this idea that with a time-shared system, you could share files. And when he had the ARPANET available, he said, why don't I just send a file from one machine to another? And then he had to figure out, how do I make sure it gets to the right machine and to the right user? And so he needed a way of expressing the user and the machine names. And he said, how do I separate them? And he looked for a symbol on the keyboard that wasn't already in use as an escape character by some operating system. And the @ sign was the only one available. So that's where @ came from. So user at host was the way in which email was characterized way back in 1971. And of course, we still persist that in that way today. We had an international network working group that became part of IFEP that I was asked to run. And so that group encompassed lots of people from Europe and from Asia. So anybody that tells you that the internet's evolution was purely a US thing is wrong. We had University College London, we had NDRE, the Norwegians, we had the Germans and the Italians and the Japanese, and others were involved fairly early on in the evolution of the net, contributing to various aspects of it, whether it was the packet satellite net or some of the protocols. The first proposal for the internet design came in '73, and that Bob Kahn and I wrote. And in that same time frame, Bob Metcalf at Xerox PARC invented Ethernet, which didn't go anywhere inside of PARC. It had to leave PARC and along with Bob Metcalf to start a company to commercialize Ethernet. PARC had a real problem. They had these brilliant people, but they didn't know how to commercialize what they did. There's a book called Fumbling the Future, which is all about Xerox inventing massively wonderful things, but not necessarily turning them into businesses. Steve Jobs wandered through Xerox PARC, had a look at their Alto machine, and went off and did the Lisa, which didn't work out very well, but the Macintosh was great. So by 1974, we published the first paper on the design of internet. This is one of the first examples of government stepping back. Bob and I actually thought about whether we should patent any of the technology. And although as a government employee you can't copyright things, you can patent things. And we thought about that, actually, and decided it would be a bad idea, and concluded that the best thing to do was to release this completely publicly with no constraints whatsoever. Now, keep in mind, this is in the middle of the Cold War. And we're sitting here thinking, okay, this technology is intended to be used for command and control. But we said, if it's going to be used for command and control, we need to think about our allies, because we will want them to be able to interwork with us. So they need to know how this stuff works. And then we said, okay, who are our allies now? And then we said, who will be our allies 25 years from now? And we weren't sure, because if you went back 25 years, you discovered that people who were friends now were not friends back then. And so we gave up and said, we'll just have to release it to everybody in the expectation that whoever our allies are will have access to this technology. And so we chose to release this completely without any restriction at all. Some people have asked us, how did you get away with that? Especially given the conditions at the time. And the answer is, we didn't ask permission, we just did it. And nobody noticed. So, you know, sometimes, Grace Hopper was known for the same thing. You know, it's easier to beg for forgiveness than it is to ask for permission. So we just released it. There are other things happening here, like the first implementations of TCP, one of which was done in England at University College London. Ray Tomlinson at Bolt, Beranek and Newman did the second one, and my team at Stanford did the first one. Oh, that's a mistake. It wasn't UCLA. That's an error. That should be Stanford. Wow, how embarrassing. Okay, I'll have to fix that. We started to see some competing technologies show up. X25 was started by Larry Roberts, who had run the ARPANET program at ARPA and then left to run Telenet, which was a spin out from Bolt, Beranek and Newman. And he asked me, you know, what protocol should I use? And he asked this question in '75, just as we started implementing the first TCP. And I said, you should use TCP. And he said, I can't sell that. And he said, what do you mean? He said, well, it's packet switched. And I said, yeah, that was the idea when you did the ARPANET. He said, but nobody knows what datagrams are. Nobody knows what packets are. People know what circuits are. So I'm going to build a virtual circuit system so I can sell people a virtual circuit that's cheaper than a real circuit. So he went down the X25 path and standardized that at CCITT. So there were battles for many, many years over which protocol would become the common protocol for the world. And I can tell you that in the end, I always told everybody that IP runs over everything, including you if you're not paying attention. So it runs over X25, and it runs over relay, it runs over ATM, it runs over dense wavelength division multiplex. It'll run over anything that will carry bits. And this very general characteristic of the internet protocol is what has made it so flexible. So I've already mentioned the 3-network demo. We standardized the TCP IP protocols through DoD. So there was an official release of standardization in DoD in 1982. And in 1970, actually there was the first release in 78 and then another one in 82. In 78, the Open Systems Interconnection guys decided that they didn't want to have anything to do with this military protocol. I mean, how could they possibly accept something in Europe from the US Defense Department? You know, how outrageous. So they went off down their own path to do what was called Open Systems Interconnection. The battle went on for 15 years. In 1979, I'm still at ARPA, and Bob Kahn looks at me and he says, you know, I know you're running this program and everything, but what if a bus runs over you? And then, you know, what will people know about what was in your head? And he said, you need to do something about that. So I started something called the Internet Configuration Control Board. We tried to make it as boring sounding as possible so nobody would want to be on it. And then I asked the guys who were actually doing the research to be part of that. That turned into the Internet Architecture Board many years later, which spun off the IETF. The National Science Foundation started to get interested in this. There's another example of how powerful the collaboration was among the various agencies in those years. NSF, first of all, noticed the success of ARPANET and wanted to do something for the computer science community that had not been supported by ARPA, and they started something called CSNet. The guy that did that, Larry Landweber, was at Wisconsin at the time, And he came to me saying, what should I do? And I said, why don't you use TCP/IP? Because I was, of course, the evangelist for that then, as I am now at Google. So he agreed to do that. And NSF actually took some risk in doing this, because in 1981, this was not exactly a done deal. Although by this time, we had standardized the protocols, and we were just implementing them on every operating system we could find. By 1983, we had the 3 networks plus Ethernet running, packet satellite, packet radio, and ARPANET, plus Ethernets, and we turned on the internet on January 1st. Now, at that point, a very interesting thing happened, because during 1983, the ARPANET, which included the Defense Department locations and the academic locations, were separated into ARPANET and MILNET. And then MILNET eventually morphed into NIPRNet, CIPRNet, and so on. But that was a very important year in the history of internet. We're starting to see the separation of the networks into different parts. By 1984, the internet is now has a year of operation or so, and we're now starting to see that John Postel with his notebook is not going to be enough to handle the domain name system. And so Paul Makapetris and John got together and developed the domain name system, which is, as you know, a nice big expandable distributed filing system for resolving domain names into IP addresses. So that comes pretty early on in the operational internet phases. Again, an important note is that this was being funded by the Defense Department and later by NSF. It was free. You just called up John and got a domain name. The Network Information Center at SRI International did a lot of the bookkeeping for John on domain name allocations. So this was not a monetized thing at all. It was free of charge, supported by the government. By 1985, we had 13 root zone servers, and here we had collaboration between the private sector and the government. Some military sites are still running root zones, root servers, and some are commercial entities. Some are outside the United States, like RIPE NCC. The Internet Engineering Task Force gets formally created in 1986. There were 20 people participating in the IETF. We had the first meeting around a conference table. Today, there's more like 1,500 people who come for a week, and 100 different sessions happen during the course of that week. Something on the order of 7,500 RFCs had now been produced. At the time, in 1986, the numbers were a lot smaller. By 1986, also, something that had originally been called the FRIC, which is the Federal Research Internet Coordinating Committee, which is made up of the program managers at DARPA, NSF, NASA, and DOE. Those 4 people were the core of Internet's evolution in the early days. That was replaced by the Federal Networking Council, which included not only those 4 core program managers, but others from other agencies around the US. But again, it's 1986. It's still US government largely managing this enterprise. We're starting to see commercial entities. 1984, Cisco Systems and Proteon start producing hardware in order to allow universities especially to buy routers, because the way we used to do routers is you get a computer and a graduate student, and you wrap the graduate student around the computer, and that turned it into a router, but we were running out of graduate students. So this was a way of commercializing that. So we're starting to see no commercial service, just commercial equipment and software. Sun Microsystems, for example, and others. In 1988 was a very big deal for me personally. I had joined MCI after leaving ARPA in 1982, late 82, and built for MCI something called MCI Mail, which was a commercial electronic mail service. And after several years, and that sort of stabilized, I rejoined Bob Kahn and his company, the Corporation for National Research Initiatives, which he still runs. And in '88, I proposed to the Federal Networking Council that they allow me to experiment by connecting the commercial MCI mail system to the internet, specifically the NSFNet component. And what was interesting about this is that I posed this as a technical question. Can I get the MCI mail system, which I had designed, to interwork with the electronic mail service of the internet, which Ray Tomlinson and others designed. So I posed this as a technical problem. But the honest truth is I wanted to break the barrier that said no commercial traffic will be allowed to go on the government-sponsored backbones. That was my hidden purpose. And they said yes. And I think they actually knew what was going on, but they said yes anyway. And so we turned up commercial linkages to the internet in 1989. And as soon as I announced that MCI Mail could connect to the internet backbone, all the other commercial email carriers said, wait a minute, those MCI people can't have that special privilege. And so Telemail from Telenet and OnTime from TimeNet and Genie's, Geisco, whatever it was, and CompuServe, all hooked up to the internet. Now, the interesting thing is two things happen. First of all, the private sector is seeing the utility of networking without having to have built a backbone. They were just connected at the edges. The second thing that was even more interesting is that those email systems, before connecting to the internet, were completely isolated from each other. Their formats and protocols were completely different. They all had to adopt the internet protocol in order to push traffic in and out of the internet, which meant they could communicate with each other. So suddenly, these guys who thought they were running walled gardens found out that all of their competitors could communicate with their customers because the whole thing would go back and forth through the internet. And that was a bit of a shock. And later on, of course, email became a free service, and most of those companies, including MCI Mail, didn't work anymore as a business model. But it worked just fine, technically speaking. So we start to see the same year commercial internet service. So there were 3 commercial carriers in 1989. UUNet here in this area, PSINet also here in this area, and SurfNet out in San Diego. And yes, I know that's my last name. They didn't intend it that way. Originally it was called SURFNet because that's what you do in San Diego. Except they discovered, the whole thing all worked out with t-shirts and surfing the net and all that stuff. And then they discovered just before launch that a company in the Netherlands called SURFNet was already in operation, had that name. They said, what are we going to do? And somebody said, why don't we call ourselves the California Educational Research Foundation Network? SurfNet sounds the same. Then somebody said, maybe we should call Vint. So they called me and they said, is it okay if we name our network, CERFNet? And my first reaction was, geez, if they screw it up, am I going to be embarrassed? And then I thought, wait a minute, people name their kids after other people, and if the kids don't come out right, they don't blame the people they named them after. So I said, sure, go ahead. So we flew out to San Diego on July 10th, 1989, I guess, and took one of those plastic bottles full of glitter that they use in the Hollywood movies, and we smashed it over a Cisco router to launch the SurfNet. So those 3 were in operation, and they formed a commercial internet exchange to make sure that their interconnections were not going over the government backbone in case the government decided they couldn't pass traffic anymore. As it happens, all of those things got resolved. And in fact, in did I miss? I missed one. Oh, the World Wide Web. Oh, that's important, the World Wide Web. In 1992, just to jump ahead a bit, there was a law passed called the Voucher Bill, which formalized the permission of traffic, commercial traffic, to flow on the government backbones under the appropriate circumstances. 1990 was a big year because the ARPANET was retired that year, and everything moved off onto NSF backbone, for example. In fact, not long after that, all of those networks, the Packet Radio Net, Packet Satellite Net, and the ARPANET all went away, but the internet persisted because it wasn't a physical thing as much as it was an architecture and a set of protocols that made things work. Tim Berners-Lee releases his version of the World Wide Web in late, like December 1991, and nobody noticed. But in 1992, here's another example. We'll get back to the World Wide Web in just a second. 1992, the Internet Society gets formed. Why did we do that? Because in 1990, NSF said to me, we're not paying for the Secretariat for the IETF anymore. It's now something that's become so commercial, that it's supported by and populated by both academics and largely by industry. we don't want to spend research money supporting the Secretariat for that function. So I said, okay, I understand that. Once again, government stepping back. And so I said, all right, we had to find a way to generate funds. So I'll start this nonprofit internet society with Bob Kahn's help and the help of the Internet Architecture Board. And we'll make that a membership thing. And we'll charge people to be members of the Internet Society. We actually thought that a society would emerge out of the connectivity of the Internet. And I think we're seeing many societies emerging out of the connectivity of the Internet. But that institution has been in operation since 1992. It's about a $50 or $60 million a year operation, and it in fact does support the IETF and the IAB and the IRTF. And it does this primarily because it runs the company, or owns the company, that runs the .org top-level domain. And that's a business that generates a substantial amount of revenue, and it supports the not-profit Internet Society. Mosaic pops up. This is the browser that some of you probably discovered in 1993, written by Mark Andreessen and Eric Bina, who decided to make a graphical browser so that it would be able to display text and imagery and format it. It made the internet look like a magazine. It got everybody's attention, and including a guy named Jim Clark, who had started Silicon Graphics on the basis of an ARPA research project that he did called the Geometry Engine. So that chip was the core of the Silicon Graphics machines. He sort of departed from that and started Netscape Communications after spiriting Mark Andreessen and Eric Bina to the West Coast. So the Mosaic browser got everybody's attention. It was originally built at the National Center for Supercomputer Applications, but it must have been downloaded 1 million times or something in the 1993 period. And now the next thing happens. NSF becomes instead of DARPA or DISA, NSF now inherits the responsibility for the domain name system, and so it issues a request for proposal, and the winning contractor is Network Solutions. And so it's contracted now, again, paid for still by research dollars in 1993 to run .com, .net, and .org. We separately .mil and .gov and so on, .edu were run by other agents. Netscape Communications gets started in 1994, so we're starting to see a commercial emergence now of services on the internet which are commercially available now that we have commercial backbone service as well. And NSFNet gets retired. This is another major milestone. And what happens in this case is really interesting. NSF had made this backbone connect 3,000 universities around the US. It paid for the NSFNet backbone for a period from 1985 to 1995, about 10 years. And it observes by this time that there's commercial service available to everybody, and so it doesn't need an NSFNet backbone anymore. And it decides to just close it down and tell the universities, go buy service. I mean, they may still pay for the service with NSF grants, but NSF is not running the network. So again, NSF steps away, but it does it in a very responsible way. They don't want to lose all the connectivity that the NSFNet had offered, and so they said, we will fund network access points where the commercial networks can meet and exchange traffic, and we will fund more than one of them so that you have some physical dispersion, and we will fund them on a declining basis. So they start them out with a certain amount of money, and they say over a period of 3 years, it actually turned out to be more like 5, we will decline, we reduce the funding for you. You have to figure out a business model to be self-sustaining. Now that was a gutsy move, and it was a brilliant move that they made, which introduced yet another commercial element in the growing nexus of the internet. And so that was a huge milestone and executed extremely well. One thing I think I may have left out, let me go back for a second, no. Somewhere in this 93, 94 period, I think, it may even have been as early as 92, NSF is also noticing that it's costing them a lot of money to support the domain name system registrations because they're starting to mount into the hundreds of thousands and millions. And they're thinking, quite properly, wait a minute, we're paying research dollars for what looks to us like a commercial business. Why are we doing that? And so the guys at Network Solutions said, well, okay, could we charge for it? And NSF says, well, why not? So they said, well, how much are you going to charge? He says, well, we don't know exactly, but how about $50 per domain name per year in 2 years, $100. If somebody's going to need and use a domain name, $100 doesn't sound like it's going to break the bank. So they go into commercial operation. And immediately the Congress erupts and decides that this is an illegal tax that somehow, oh yes, any excess money that may have been made by Network Solutions is supposed to come back to NSF to be spent for the benefit of the internet research. And you can guess which side of the House decided this was a bad thing. My erstwhile colleague from Stanford University, Jim Sensenbrenner, was the chairman of the Judiciary Committee at the time. And he erupted pretty violently and said, you know, this is an illegal tax. And there was a big hoo-ha. And eventually the numbers came down and no money came back to NSF. I don't know, I thought it was a pretty clever idea myself as a way of augmenting the stingy research budgets that the Congress was handing out and still tends to hand out today. Okay, that's a commercial. So this turned out to be yet another very important thing because now the domain name system became a self-supporting enterprise. It's actually a big enterprise now. There are hundreds of millions of domain names and lots of money to be made, not only in the business of registering and maintaining domain names, but also speculating in domain names. These are called domainers. I hate it. I think it's an awful practice. But you know, that's what private sector is all about. If somebody can make a buck, they'll figure it out. And so people still do this speculation about domain names, but we're way ahead of the story here. This is just an infographic about the changing institutions of the internet over time, and we don't need to go through a lot of detail, except to say that one of the nice things about the internet development is that when new institutions were needed, they got invented. We didn't start out by inventing them, we invented them when we needed them. So the Internet Architecture Board and the ICCB and the IETF got invented when it was necessary. And that's made a big difference, I think, for the Internet's institutional history. So then comes 1996, and it's becoming very clear that this domain name thing should not necessarily be the responsibility of the government. And so the community that was dealing with the domain names, and in particular John Postel, who's still at ISI, USC ISI, the lawyers there are saying, we're getting nervous about this domain name thing. You know, it's big business. We could get sued. You know, how do we avoid that? And John made an attempt to externalize the domain name management, top-level management. And there were a 2-year period of discussions among the community. Some people wanted to set up an organization in Switzerland. And as soon as it was proposed to do anything outside the United States, the Congress erupts again. You're pissing away American control of the internet. And so it reached a very, very high level of intensity, and it landed on Bill Clinton's desk. And Bill handed the problem to Ira Magaziner. So Ira Magaziner starts consulting with everybody under the sun, issues a green paper, revises it based on comments, and produces a white paper describing a private sector institution, which today is called the Internet Corporation for Assigned Names and Numbers. That organization was created in 1998. Just prior to its creation, the institution for handing out internet addresses was also expanded and separated from government management, and it's called, here in the US, it's called the Emergence Registry for Internet Numbers. I'm still chairman of the board of that organization, and it hands out internet addresses for Canada, the US, and some of the Caribbean countries. So in 1998, ICANN gets started, And the irony of all this is John was going to be the chief technology officer for ICANN, having done this work for 30 years or so, and he died literally 2 weeks before ICANN was formally inaugurated. And NSF at that point handed off the tar baby to the National Telecommunications and Information Agency, and you can kind of see why. It's, NSF is a research institution, NTIA is about commerce. And this thing had become clearly very commercial. So once again, you can see the government trying to move its responsibility to a place that makes sense. And in this case, NTIA was the stuckee. Other parts of the domain name and the IP address allocation systems were created in that same general time frame after ICANN was formed. And then comes 2003. And the International Telecommunications Union, realizing that the telephone system is not the latest technology in the world anymore, got very interested in what this information society might look like. So it initiates this World Summit on the Information Society in 2003. And the first thing that happens, this is an intergovernmental group, right? Because the ITU is a multilateral group. And so these representatives from the government said, what's an information society? And nobody knew, but somebody said, well, it's kind of like the internet. The first question these representatives asked is, who's in charge of the internet? And we said, well, nobody, it's fully distributed. And they wouldn't believe us. They said nothing on that scale could possibly not be run by a single central organization. Then they found ICANN. I was chairman of the board of ICANN at this point. And had been for several years. And so they decided ICANN must run the internet because it was the only central thing they could find. Then they said, who's in charge of ICANN? And they discovered NTIA. So they decided the US is in charge of the internet. Now, this is a gross misstatement given the fact that 99.9% of all the assets of the internet are in private sector hands for the most part. And all the functionality and everything else is being run in the private sector as well. But these folks decided that the US was still in charge of the internet. So they couldn't figure this out, so they had a working group on internet governance, which couldn't figure out exactly what to do either. And so at the end of the World Summit on the Information Society, the working group on internet governance said, why don't we create an internet governance forum where we can talk about this some more? So the IGF has been running since 2006. And it just had its, or will have its 10th, it'll have its 11th meeting this year in Mexico. So what's happening here is that governments, and especially the US government, is stepping back repeatedly, trying to move all this stuff into the private sector. In this last 6 or 7 years or so, there have been lots and lots of efforts to coordinate among the various parts of the internet governance ecosystem, especially the Internet Society and ICANN and IAB and so on. In 2014, one of the most unusual meetings was held. Keep in mind, this is after Snowden. And that, of course, created a huge hoo-ha everywhere because there were all kinds of assumptions made about the private sector being in cahoots with the NSA, et cetera, et cetera. And the then and still president of Brazil, Dilma Rousseff, complained that her mobile had been tapped by NSA. So she was very unfriendly about internet and the US and everything else. The then CEO of ICANN actually confronted the president of Brazil with an opportunity to do something about this by hosting a meeting called Net Mundial, the World Net, in Brazil, and proposed that she, in fact, invite people to come down to talk about internet governance in Brazil. Sort of this talk about walking into the lion's den. So that meeting was extraordinary because the people who ran it very carefully made sure that everybody had an equal opportunity to speak. So they had the technical community, governments, the civil society, and the business, private sector, the civil society, governments, and the technical community, each got to line up at 4 different microphones, and they just cycled through them. So it was absolutely equal access to speak on this thing. And what came out was a statement of principles that was not a wishy-washy statement. It was a very strong statement of principles that we should preserve in the internet, including openness and accessibility and things like that. So that turned out to be a big milestone in terms of internet governance. And the US had a good role to play there. Our State Department was well represented. So what has now happened is the last step in 2014, NTIA announced that it was prepared to terminate its oversight of ICANN. It's the last remaining vestige of formal US responsibility. And they proposed that in March of 2014. It led to a gigantic 2-year discussion about how ICANN would operate without the benefit of NTIA oversight and a contract to perform their function. And the proposals have gone now to NTIA from the community after these almost 2 years of discussion. NTIA has roughly until the end of September to decide whether it's going to act on the proposals. It has obligated itself to the Congress to provide Congress with briefings and an opportunity to discuss the proposal for a 30-day period. And so we are literally this year coming to the last chapter of formal internet oversight by the US government. And I would suggest to you that the US government has really done a good job of pushing all of this stuff out into the private sector over the period of time that this story has been underway since 1969. So over a 40-year plus, 45-year plus period, I think the various parts of the US government, including ONR, the research community, deserves a lot of credit for having taken those steps consciously to try to turn this into the global enterprise, which it needs to be and has turned into. So I'll stop there. I realize I've gone way over time. I apologize for that. But if you want to hang around for Q&A, I'm okay to do that too. Otherwise, everybody can just go back to work. But I thank you very much for your time.